Part one of the computer project is what we call the Vhdl shell. So what you want to do in this part is get all of the files created for the computer, get all of their entities created, and do any instantiations that are necessary within each of the components in order to verify that all of the ports for that particular entity are mapped into the lower level component accurately. That will involve creating some internal signals to do some wiring in some cases. In other cases, you might just directly connect ports of an upper level entity to the ports of a lower level component. But this is very critical because you want to separate debugging whether things are wired correctly from the actual functionality that you're going to create. So as part of this, what you're going to want to do is you're going to want to do the 13.1 multiple choice quiz on computer hardware terminology, just so that we're talking the same language. The next thing you want to do is do the 13.2 multiple choice quiz on computer software, again, just for terminology. Then you're actually going to make a Modelsim project and you're going to create separate files. And it's critical that you name them exactly the way that I'm naming them so that it's easy to communicate amongst or back and forth between what you're doing and the handout and what you're doing and me and what you're doing and the textbook itself. So you're going to have 8 unique VHDL files starting with computer. Underneath it you're going to have CPU and memory. Underneath the CPU you're going to have controller unit and data path. Under memory you're going to have ROM and read write. And then under data path you'll have the ALU. You don't need to add any functionality in here. That you are not going to be doing any register definitions or any finite state machine implementation. This is just wiring the thing up. Okay. When you do this, you will be able to run a simulation, and the simulation will fail if any of the connections are wrong or if they're dangling. And so what you're trying to do is get a simulation to run that will not error out. And when you do this, you'll actually see a message in the simulation test bench that the simulation ran without any errors. Okay, so this right here is going to be your deliverable, is a screenshot of the transcript that says there were no errors in here. Okay, so let's take a look at how we're going to do this and how we're going to debug it. So the first thing you want to do is launch Modelsim, and I'll walk you through a few of them. So I'm going to do File, New, Project, and what I've done is I've created a new folder for this this project, and I'm going to call it Computer. And I'll go ahead and I'm going to call the name of it Project. And now here I am. The first thing I want to do is there is a test bench for this on the website. So you go ahead and download it, and it is called computer.tb. So I already downloaded it, and I open it, computer_testbench.vhd, and I already had downloaded it and put it in my computer project. And I'm going to go ahead and take a look at this, because this is how you get started with this tops-down entity design. When I look at this, I see library IEEE, library standard logic, okay. It's a test bench, computer TB, you know, the entity doesn't have any ports. And then I see the component called computer. The reason that I open this first is because, remember, this test bench is calling my computer. So I want to be able to see what ports it is expecting. So if you think about it, you got clock, you got reset, port in 0 up to 01 down to 15, and then you got 00 to 15. This computer, you know, component declaration is exactly what is in the in the block diagrams in the handout. So if you come back to the handout and you take a look down here at the computer, so here's the computer, what you'll see is that this thing has the ports 00 to 15, and then it has, those are inputs and these are the outputs 00 to 15. It's got clock and reset. That's it. At this level, there is nothing more that is there. So that entity that is being essentially defined for you in the component declaration of the test bench is the port naming convention that you should use when you create the computer.bhd. So it's a simple copy and paste. So let's take a look at how we want to do that. I look at this component, it's computer, it's got all this stuff. If I look at, before I go, what it's connected up to, in the test bench we created a whole bunch of signals called whatever _TB. And then all we did was we instantiated it and we just wired them all up together. And then you got to think about, what is the test bench driving in? Well, I do a header, which just says the simulation starting. Then I do a clock, of course, so the clock is going to toggle. And then I do a reset. And then I just drive some constants to the input ports. Notice that the output ports are driven by the DUT itself, so you don't actually wire them to anything other than the internal signals that we'll observe with the waveforms. We do want something on the input ports so that we know, like if we want to load from one of these, we want a value that we know what it is before we actually do the instruction. And so that's the whole test bench. And this is very simple, but that's how a computer is all it does is it reads information or loads information from input ports, and then it does a bunch of manipulations, and then it puts it out on an output port. And so the test bench doesn't have a lot of functionality in it. The functionality is all in your register transfer information and also in your finite state machine. Okay? But more importantly, if I come up to this computer, declaration, I can copy and paste this into my new computer.vhd file. Okay, so the first thing I'm going to do is I'm going to come back here, and this is what I'm creating, computer.vhd. All right, and I'm going to go ahead and come back to Modelsim, and I'm going to go File, New, and I'm going to do, actually I'm going to go Add to Project, New File. I'm going to call this computer.vhd. Now I have my computer.vhd, and I'm going to go ahead and start off, and I'm going to paste my component declaration that I got from the test bench. I'll clean that up in a second. Let's start at the top though. I'm going to grab the library. So I copy and paste, and I go ahead and put that as my library. And now what I want to do is I'm going to come here and I'm going to go Entity Computer is, and then look at my ports. I have now defined all the ports for this computer. And once I get to the end, I say end entity, and this now was the entity definition. That's just like we've done on every other project. Now we're not done with the computer yet, right? If you think about what needs to happen, we need to have a CPU and a memory component within the computer. So let's keep going. So I'm going to say, okay, I end my entity. I'm going to go architecture, and then I'm going to call this computer arc of computer is. I come down a little bit, and I'm going to do a begin, and then I'm going to come down here and I'm going to say end architecture. And at this point I want to give it a compile. So let's go ahead and compile all and make sure that everybody is alive in the simulator. It's like, okay, no errors, which we wouldn't expect at this point. Now I want you to think about the logic or the functionality that will be inside of this. We have computer.vhd and we have the ports. Okay, ports in, ports out, clock reset. That's good. Underneath, we are going to have two new components that we are going to declare that will be individual files. But the way that you do it is declare the component first and then go design the file for the VHDL. So if I do the component definition or declaration for the CPU.vhd, I will define all of these buses, or excuse me, these ports. Then I can copy and paste that into the CPU.vhdl file when I create it, just like we did when we created the computer.vhd. We let the upper level, which was the test bench in this case, define the ports for computer.vhd. Then when I created the computer.vhd file, I just copied and pasted it, and I didn't have any ambiguity. Okay, so let's do that. So we have this sitting here, and let's take a look at how we're going to do this. So I'm going to come down here, and I'm going to say component, and then I'm going to do the following. So I have the component, and the name of it is going to be called CPU. All right. Now when I do this, I kind of want to be able to see what I'm trying to code up. So I'm going to pop this little, I'm going to undock my computer or my editor here. And what I'll do is I'll try to bring this to the front here. So now I've got this, I've got this block diagram right there, and here now is my computer. And it's obviously a little hard to get everything on the same screen here, but let's see, I'm looking at the CPU under there. Okay, so that's probably good enough. All right, so I come down here and I've got component CPU. And now what I want to do is I want to do the port definitions for this. So I'm going to say port, and I'm going to start always with clock, and I'll go ahead and do it's of type in standard logic. And then what I'll do is I'll get my reset, and then I'll come over here in standard logic. And then what I'm going to do is I need some signals in here. So I'm going to need these signals right here, address, write, to memory, and from memory. And so here we go. So what I'm going to start with is, for no reason, you can put them in whatever order you want, but I just say to memory. Actually, let's just do address. It makes a lot more sense to do address, and it's going to be, it's an output, right? And it's going to be standard logic vector. And I'm not going to do all this for you. Just want to get you started. So 7 down to 0. And then the next one is going to be write, and we'll make that an output, standard logic. And then we'll have to memory, and then that will be a standard logic vector. And it's, of course, an output. So we'll do out, standard logic vector. And it's going to be 8-bit, so 7 down to 0. All right, and then finally we have from memory. So you got from memory, and it is also, it's an input, and it's going to be standard logic vector, 7 down to 0. Okay, so I've got all these. This is my ports here. Everything is great. And what I want to do is, since this is the last one, I'll go ahead and end that. And then, of course, since we're going to be doing a lot of copy and pasting, go ahead and take the time to clean these up, right? So it's like, okay, so I'm going to get everything lined up because we want to be able to make it readable so we know what's going on as we go forward. And now I do end component. So I say end component. And when I did this, component, when I did this, I now defined the actual port definition for the lower level entity cpu.vhd, which hasn't even been created yet. And I should be able to compile this. So if I go ahead and go back into my VHDL or back into Modelsim, I pop this, I docked it back in there, I should be able to go compile selected, and everything works fine. So it worked. The reason that write changed colors was because it's a keyword for something, but it doesn't matter. You can leave it as is. It just says that it's notifying you that it's a keyword in a specific other function, but it'll work just fine. Okay, so it didn't error out because I didn't do anything other than define this. So I want to also do the memory system, and then I want to wire it together. And so I'm sitting here and I'm like, let's do the memory system and see what happens next. So let's go ahead and get the memory system on here. So now I got the memory system, and let me undock my window. And now here I am again. So now what I've got is I have my VHDL editor, and I've got the memory system right here, and now I want to code this up. So I'm going to do another component declaration, and I'm going to call it memory because that's what it's actually called right there. And then I'm going to do this port definition. Now this is where the things start getting very, very large because you have clock and reset, and in fact you actually have a lot of these things right here. So why don't I just copy and paste this and see what's going to happen here. So let's just copy and paste an update. I copy and paste that, and I'm looking at what's on the memory in terms of inputs. Clock and reset are obviously inputs. Here comes address. As a memory system, it's not an output, it's an input, so I'll change that. Write is coming in, that's fine, but it's no longer an output, it's an input. And then we have these two ports which for the CPU calls them to memory, but on the memory system I'm going to call it data in, and those are named differently specifically to keep track of for the memory system itself. You want to know what's coming in and going out, so you're always thinking about these when you design them as your perspective. Okay, so then the data out is going to be the bus that goes out of the memory system. So all I need to do is change that to be an input and this to be an output, and I've now defined the big signals for the memory system. What we don't have is the ports. Okay, so now at this point we're going to do a whole lot of copying and pasting. We need to define these ports. So if I do one, I can copy and paste like crazy. So if I do port in 00, I can come over here and say it's an input, it's a standard logic vector, 7 down to 0, and I'm like, okay, so that was good, but guess what, there's 16 of them. So now this is where you get to do some serious copying and pasting and updating. Okay, so I got the entire thing declared, and I'll go ahead and remove those spaces so that it's a little bit more compact. And now what I want to do is end this component up. So I'm going to go ahead in here, and what I'll do is I'll end it with a final closing parentheses, and I'll go ahead and do an end component. Okay, so I save that up. I'm going to go ahead and put this back into Modelsim. So I dock it again. I go back to Modelsim, and let's compile, select it. Okay, life is good. At this point, I need to think about the functionality that I now need to do. The functionality for this is actually wiring these together. All I've done when I did those component declarations is I said there will be something called cpu.vhd that I will use. I might use it once, I might use it 1,000 times. There will be something called memory.vhd that I will use. I might use it once, I might use it 1,000,000 times. But now I need to wire it. When I instantiate it, I drop it into my design. Then I need to think about wiring it up. Okay, so that's where you start thinking about, do I need internal signals, or do I just connect them directly to the ports? You'll notice immediately you need 1, 2, 3, 4 new internal signal declarations in order to wire up the address bus, write, to memory, and from memory. You do not need new signals for the ports because you can wire the port directly from the computer, the port name port in00, directly to the memory system port. Okay, so we can use this name that was defined in the entity of the computer down here to the port definition of the memory system. Same thing with port out. So that makes it a little bit easier. We do need internal signals here, but we don't need internal signals there. Okay, well that's good. So let's do this. Let's put this back over here. Let's go back to Modelsim. And I need to now, let me undock this. And I'm back to here and here. Okay, so I'm going to come down here, and I'm not at the begin yet. I'm still declaring stuff. So I need to come over here, and I need to start doing some signals. So I'm going to do signal, and now at this point, you want to name these something descriptive. You could just call it address, I guess. Yeah, that's fine. You can call it whatever you want. But you should name it something specific so that you know when you look at this, it's at this level. And I'll show you how you can see that in the second part of this. So I'm going to do standard logic vector 7 down to 0. Okay. And we just declared that. So that signal will be this guy right here. Okay. All right, life is good. Let's go ahead and come here and let's copy and paste this. The next one we're going to do is write. So we need write to be this connection right here. So in this situation, it's just standard logic or standard logic. And now we need this guy right here, to memory. Now you can call it anything you want. I'm just going to call it to memory, and I'm going to do that because for no reason. You can either call it like to memory. It's this signal bus right here. So you got to think about at this level, the computer, it's this right here. So you could call it CPU to memory, you could call it memory data in, or you could call it anything you wanted to. So you could call it computer data over or something like that. I'm just going to name it what I named the CPU, and you can do this any way that you want. So I'm going to create a signal called to memory, and I just got to keep in mind that that's with respect to the CPU. So I do from memory. Okay, so I got all my signals that I need. Okay, I only needed to declare 4 of those things, and they don't have direction, right? They're just wires, so we wire them up. Since I'm sitting here, I want to make sure that I can compile that. I don't want to go further without compiling, so compile selected, good to go. All right, so now I've got my thing right here. I've got my code, and it's time to actually instantiate these things. So now what I want to do is I'm going to come over here, and I'm going to give this, I'm going to instantiate the CPU. I'm going to give this something specific. I'm going to call it like CPU_1, and I'm going to now call CPU. I'm finally at the point where I'm going to wire this up. This is critical. When you connect these up, use explicit port mapping. Do not use positional port mapping. It will destroy you. You want to make sure that you have specific mappings. For example, when I do CPU, I'm going to do the port map, and I'm going to start right off, and I'm going to say clock gets wired to What? Well, you're the CPU right here. You have an input named clock. I'm going to wire it to the clock input port of the computer. So I just flat out do clock, comma. Now I'm ready to do reset. Reset gets attached to, reset. That was the reset of the CPU got wired directly to the reset of the computer. All right, now what's next? Well, I have this port right here, and I need to come up here and think about this. I've got these ports right here. I can copy and paste this down here. Why don't I do that? I'm going to copy and paste this down here so I don't forget what I'm doing. Now I'm just going to put a temporary code down here so I can see it. So the next one that I need is address. So the name of the input port, or excuse me, the output port of the CPU is called address, and I'm going to wire it to what? Well, it's an internal bus, so I'm going to wire it to this new signal that I created called address. There you go. So I wired that, and then I'm going to wire my write output over to the signal I called write, and then I'm going to do to memory, connect that to this new signal that I called to memory, and I just got to remember where that is. It's the to memory signal within the computer level, and then finally I go from memory, and I say from memory, and then that is it. Okay, so let's clean this up. Let's get a compile going here to make sure that we're okay. Okay, so come over here. Everybody's clean it up. Okay, that right there is my component deck or instantiation. So I've actually added functionality. What's interesting about this is that I instantiated it. Okay, so now let's go ahead and compile, and let's make sure that it works. So it worked. Okay, and if I can't see that after I get so many compiles, I just clear the transcript, compile, selected. Okay, good to go. Now I need to instantiate the memory system. So now here is where I start thinking about, okay, I need, it's going to be called mem. I'll call it mem so it's kind of easy to see. And I'm going to do memory was the name of it, but now, holy cow, we need a whole lot of stuff. Okay, so I need to come up here and think about what's going on. So I've got clock, reset, write, data in, data out. I'm going to copy and paste those just so I can see them. Okay, that's just temporary. I'm just going to put them down here so I can see it. I've got clock and reset. That's good. The next one for the memory system is called address. Okay, and now when I think about what I'm doing now, I want to have this drawing up. I want to think about, I am sitting at the memory. Okay, so this is the input coming in. So this port of the memory is connected to this new signal that I called address. So it's called address coming out of the CPU. It's called address at the computer level, this bus, and it's called address coming in. So that one's pretty easy to do. Okay. The other thing I can do is I have a write that is the port of the memory system, this guy right here, and I'm going to wire it to this internal signal I called write. Okay. This is where it gets a little confusing. You are declaring or wiring up the memory ports. So the next memory port is called data in. Okay? And that represents this connection right here. It's this port. Well, what am I connecting to it? Well, if you remember, that was an internal signal that I declared up here called to memory. All right? So it's like to memory. All right, so there's that. And then finally, we've got data out. And that's going to be called from memory. And that right there are these four internal signals that I had to create. So I've got my clock and my reset wired. I've got my 4 internal signals wired, and life is good. But we have a whole lot of ports. So think about this. Now what we need to do is come down here, and I can get rid of this temporary code right here, and I can start putting the port wiring. So I do have a port called port in 00. It is wired to what? Well, if you think about it, it's wired to the input port of the computer of the same exact name. So this is great. All I need to do here is say port in 00. And now it's copy and paste time. I have 16 of these input ports, so I need to do some copying and pasting. So let's grab these and we'll update them. Okay. So it's a lot of typing. There's a lot of typing. There's no way around it. Okay, so Control C, Control E. But this will show you kind of how to get started on this stuff. So I've got 8 now right there. Control Z, Control V. All right, and so all I got to do here is update both of these. So okay, got them wired together there. All right, life is good. Life is good. Now I'll do the output ports. So I have these 16 output ports of the memory system. Okay, this is phenomenal. So I'm now done with this, and I can actually see if this will simulate. Okay, so it should simulate right now, and this gets you started. So now I'm sitting here. You know, I can leave those spaces in there if I want to. I can tighten it up a little bit. I do want to compile. So let me put this back into there, into Modelsim. Let's go ahead and compile. We have a whole lot of code in there. 4 errors. So we now do have an error. So let's see what it is. Where could it be? Well, you double click on it, and it says port out has already been used. 116. So this is perfect. 116. I come out in here. 116. Port in 00 gets connected to port in 00, and I found my first typo. This is phenomenal. This is exactly what we were trying to figure out. Is I don't want that error to have to be fixed later. I want to get all the wiring of all the ports exactly the same. You see, again, I copied and pasted it. Look at this. So this is, you run into tons of issues like this when you do copy and pasting of huge port mappings. So you want to simulate, you want to compile these things one step at a time. Compile selected. Now we're rocking. Here's what's crazy about this is I can actually simulate this. Now there's nothing really going on. There's no output of the system. But if I simulate it, it will actually drive from the test bench all the way down through the computer, through the CPU into memory, and we can actually just verify that everything is okay so far. And this is what part 1 is all about. So what I want to do is I'm going to come down to my transcript and I'm going to clear it. And I've compiled everything about computer.vhdl. I don't even have the CPU made or the memory system made, but I can simulate this. So I'm going to go to work and I'm going to double click on this and let's just see what it does. So it flashes like crazy. Undocks everything, puts all the screens all over everywhere for no reason. I'll bring it all back onto here. It resizes everything for no reason, and I can start looking at the type of warnings that I'm going to get here. So the first thing it does is when I loaded it, it will come up here and it'll say, look, loading, warning, component institute is not bound. The reason it's saying that, I haven't created the CPU or the memory system yet. It's like, oh, this is phenomenal. So when it says not bound, that means you haven't created this stuff yet. So that means you got to go create it next. So I got to create the CPU.vhd, I got to create the memory.vhd, and I got to keep going and going and going, because anytime I instantiate it, it has to be there. It's going and looking for it. That's what not bound means. These other warnings, though, if you look at it, it's going to say no drivers exist on output port out 00. That's actually okay. So we're not going to enter the functionality that'll be driving anything to the output port yet, and that's fine. We'll do that in the next part. This is just making sure it's wiring. So you can ignore these warnings about no drivers exist. That's fine. The things you can't ignore are is not bound. Okay, it will not simulate when you do is not bound. Okay, warning, no big deal. So I go through all these, it's all these no drivers exist, totally fine. Now the key moment is I have loaded a simulation. Okay, the waveform exists. If I go to run this, so I'm going to go over here, and I'm going to go 1 micro, and I'm going to hit run on this thing. I go run. It runs, and what happened? Well, nothing really happened. So in this situation, I was concerned about all of these not bound situations. Okay, so it came up here and it said this was the one that I had to get rid of. Okay, these warnings. Okay, so this is how you do it. So this is what part 1 is all about. You are going to go in here and you are going to go through, if you go back to this very beginning of this handout, I show you kind of this map right here. Okay, so these are the files you're going to create. Computer.vhd. Underneath it, you got a CPU and you got a memory. These aren't created yet, But you can see how I use the test bench to define the entities of the computer. Then I used the computer and I declared the CPU and VHD, and I got their entities figured out before I even implemented it. Then when I go to implement the CPU, I will have the port definition for them already done, and I don't have to worry about any spellings or anything like that. So you got to create the CPU. Underneath, you're going to do control unit and data path. Underneath the data path, you'll do ALU. You create these 8 VHDL files, and then when you load them, you'll get all these warnings about whether or not they're bound or not. The bound is the key. That is what's going to tell you whether or not it can find that lower level file. In this situation, it did not because we hadn't created the CPU. But if you had anything that was mismatched, then it would also kick out an error or a warning. So that's where you're actually going to see all this magic. So once you get done with this, the deliverable is to basically, you should only have warnings in this screen that talk about no drivers exist, which are fine. All the bounds should be gone, or any errors that are wiring connection errors, those should also be gone too. Okay, so that is part 1 of this. You should create all the 8 files, compile everything correctly, and then be able to load the simulation without having any bounding errors or any wiring mismatches. And then you should be able to load the simulation and have it not crash. Okay, that is part 1.